Hello everyone, welcome to our presentation. Over the next few minutes, I, along with my teammates, will present you our business case on LASSO Tutoring Center, Data Analysis and Optimization. First of all, I would like to introduce my team members, Sweya, Gaddam, Shruthi Donthi, and myself, Nithin, Kumar, All of us are graduate students from Oklahoma State University at Stillwater campus, and our major is Management Information Systems. Now let's move on to the project. But before we get started, let me give you a fair idea about our client, the LASSO Tutoring Center. The LASSO Tutoring Center offers free tutoring services to all the students of OSU for all the different courses in their curriculums. Students schedule appointments for different courses with the LASSO tutoring staff throughout an year. Our role in our project includes analyzing, optimizing, and forecasting. LASSO Center keeps track of all the appointments that students schedule with their tutoring staff throughout an year. Our goal is to analyze this data and optimize the functioning of LASSO to increase the number of appointments that students schedule during the year 2016. Also, we would like to forecast the number of appointments that the students may schedule during the 3 semesters of 2016 individually. Now let's move on to the agenda of our project. First, we would like to discuss the objective and the methodology that we followed in the project, and then the scope. Next, we would like to discuss the 5 different phases of data preparation, which explains how we changed our data according to our analysis and requirements. Then we'll discuss data exploration and the different modeling techniques that we selected and applied on our data and assess the results of each technique. Next, we'll compare the actual outcome with the expected results and explain the lessons learned, and then we would suggest several recommendations and finally end with the future scope. Our project objective is to analyze appointment history to identify peak weeks of each semester, peak day of each week, and peak hours of the day. Also, finding the courses on demand for each semester and also the effective tutors for each course. Also, we would like to forecast the number of appointments that students may schedule for the year 2016 for each day of each and individual semesters. The methodology that we followed in our project is cross-industry standard process data mining methodology, which is known as CRISP-DM methodology. This methodology breaks the process of data mining into 6 phases: business understanding, data preparation, modeling, evaluation, and finally deployment. Now, I would like to discuss about what is in the scope and what is not. First of all, what is in the scope? The data that we were provided is of the summer, spring, and fall semesters of the year 2015, which allowed us to break the number of appointments on a weekly and daily basis. Using this, we can forecast the number of appointments that the students may schedule during the semesters of the year 2016. Also, the data that we were provided consists of appointments scheduled for different courses, which gave us an opportunity to analyze and identify the courses those are on demand during each semester. Now, what is not in the scope? We were not provided with the data prior to 2015, due to which we do not have the luxury of analyzing the historical pattern of the data. Next, we wanted to analyze and find out the effective tutors for each and every course, but unfortunately, we do not have a parameter that could justify our analysis. Also, we were not provided with the student information, as the information is a little sensitive. So, we do not have a chance to focus on the preferences of individual students. Next, we move on to the data preparation step, which consists of 5 different phases: data access, data consolidation, data cleaning, data transformation, and data reduction. Data access. The LASSO Center keeps track of all the appointments through a software called AccuSQL. The data was retrieved from the LASSO database maintained at OSU Tulsa campus. The extracted data gives a sense of how the data looked like when it was first accessed. Data consolidation. The data was provided for all the 3 semesters of the year 2015 individually. Initially, we tried to consolidate the data into a single Excel file, but it led to inconsistency in the data because the LASSO center kept on eliminating the redundant variables in their data. Hence, we decided to work on each semester data individually. Data cleaning. Two variables, lab ID and no shows, had missing values. These variables were excluded from our analysis as the missing values are greater than 50% of the data. Next, the data was provided on an appointment basis, which doesn't fit our model analysis. We excluded the variables those are irrelevant to our analysis, such as from, to, set time, and set where. Data transformation. We derived two variables, week and day of week, from the app date variable. Also, we derived a new target variable, appointments, using SAS Enterprise Guide. Data reduction. Using SQL querying, we reduced the variable subtask into another variable called course. Also, the redundant variables such as app time, end time, and sub ID were excluded from our analysis. Data exploration. Using Tableau, descriptive statistics were generated to analyze patterns in the data. Also, the data exploration step helps us in choosing the modeling techniques that are most suitable to our data and also helps in finding the anomalies in the data. As a part of the data exploration, the weeks with the highest number of appointments are identified for every semester using Tableau. In the figure, the blue line indicates the fall semester, the orange line indicates the spring semester, the green line indicates the summer semester. It can be seen that the fall semester has highest number of appointments during the weeks 7 and 14. Also, the spring semester has the highest number of appointments during the weeks 8 and 16. But it can be seen that the summer semester has almost the same number of appointments during all the weeks of the semester. As we further drill down, we observed that in any week of any semester, more number of appointments were scheduled from Monday to Wednesdays and less number of appointments were scheduled on Fridays. The courses, those are on high demand, are also identified using Tableau. It can be seen that highest number of appointments were scheduled for the course Mathematics. Also, it can be seen that most of the courses have negligible number of appointments scheduled irrespective of the semester. The distribution of appointments is highest for the fall semester, followed by spring and summer semesters. As we move on, the next part of our presentation will be explained by my teammate Shruthi Donthi.
Hi, this is Shruthi and I will be presenting the different modeling techniques used in our project. The first step in model building is data splitting, in which we basically split the data we are going to use in our model building into training and validation. For the purpose of our project, we have split the data in 80% as training and 20% as validation. I would like to let you know the reason behind this. When we were provided with the data from LASSO tutoring services, we had about some 18,000 records, but they were recorded on a per appointment basis, which we finally figured out that that was not suitable for a model building purpose. We rather had to transform the data in which we had to create a data set in such a kind that we had appointments based on per day for each course. So when we transformed the data, we were left out with about some 8,000 records. That is inclusive of all the 3 semesters. Therefore, in order to reduce the variance in our estimates, we thought that we needed more training data. So this was the reason for us to choose 80% as training and 20% as validation. Our data had categorical predictor variables, a continuous target variable, and it was basically time based. So we thought of building the following 4 models. The first being exponential smoothing, followed by neural network, and then chi-square automatic interaction detector, which was a decision tree, and then finally seasonal ARIMA model. We would be using seasonal ARIMA model to forecast the number of appointments for the future semesters. Exponential smoothing was one of our time series models which we planned to build to forecast the appointments for the 2016 semesters. But to our surprise, one of our models, mean absolute error, turned out to be 47.1, which is a very huge number, and we've thought of over this model. Hence, we went ahead with the neural network. CAID, and seasonal ARIMA models. Let's talk about our next model, neural networks. We have chosen this particular model because it's capable of handling any kind of data. We have categorical predictor variables and a continuous target variable. And neural network is something which we could reckon upon because it can literally handle any kind of data. Like it could be binary, it could be continuous, it could be categorical, anything. So the way it works is basically it has a hidden layer and has some neurons in it. The purpose is that it assigns weights to neurons, and after undergoing kind of some aggregated sum based on some transformation, the hidden layer gives us an output. So as in our slide, we have performed neural network analysis for spring, summer and fall semesters. So now here we have spring. The analysis has brought up a few statistics which are described here. The Spring 15 neural network analysis model has one hidden layer with 11 neurons, and the model has come up with an accuracy of 75.2%, which is pretty good. And the predictor importance is in the order of course, followed by week of the semester and day of the week. So in the course variable, the courses maths, physics and chemistry have the highest synaptic weights, and in the week semester we have weeks 6, 7, 9 and 14 to have the highest number of highest synaptic weights. Now for summer we have a similar trend just like the spring. We have course as the most important predictor variable, followed by week and day of week. Summer has about 84.3% accuracy. It has one hidden layer with two neurons, and the courses maths, engineering, science and accounting have the highest synaptic weights, followed by weeks 2 and 4 for the week of the semester. The fall neural network model has one hidden layer with 8 neurons, and it has an accuracy of about 82.5%, which is pretty good. And we have the predictor importance in the order of course, week and day of week. And among the course, we have the high synaptic weights for maths, chemistry and biology, whereas weeks 2, 7 and 12 have the high synaptic weights for week. Let's move on to our next model, which is the chi-square automatic interaction detector. What it does is basically it creates all the possible cross-tabulations for each category of a predictor variable. It basically has a root node which it divides into parent nodes based on the most important predictor variable, and these parent nodes are further classified into child nodes. This process goes on until it reaches the terminal node. Terminal node as in there is no further classification that's possible. We've applied this concept and we've used this concept, and we've built guide trees for spring, summer and fall. Let's have a look at the spring and summer analysis. If we see for the spring, we have course as the most important predictor variable, and we have chemistry and maths grouped into one particular category and physics into another. If we see, we can find that chemistry and maths have a more pronounced effect, or they have high frequency of appointments on Tuesdays, because after course the next split for chemistry and maths is based on day of the week. And similarly for physics, we have more number of appointments on Tuesday, Wednesday and Thursday. This is for spring. And when we move to summer, we have that engineering, science and mathematics have more number of appointments. If we see, there's no further split for summer because it has reached the terminal node and no further classification is possible. From the fall 15 tree, we can infer that chemistry and mathematics have the highest number of appointments on Monday, Tuesday and Wednesday, whereas biology on the same hand has more number of appointments during the later half of the semester, like after week 8. Last but not the least, we are here to talk about the seasonal ARIMA model, which we've built specifically to focus the number of appointments for the future semesters of 2016. We had to do a little transformation on the data because neural network and guide had a different criteria, and seasonal ARIMA has a different criteria. Nevertheless, we've done it, and we have got the mean absolute errors for spring as 1.9 and for summer as 1.6, and for fall as 2.1, which is acceptable as a very low values. From here on, my teammate Sweya would be continuing the presentation.
Now that we're done with building the models and each model has its pros and cons, we would like to assess the models based on assessment metric. The assessment metric that we chose is MAE, that is mean absolute error. Mean absolute error is the average value of the difference between the actual and predicted values, and the same is produced in the formulation. The lower is the mean absolute error of a model, the better is the model. The reason for choosing MAE as the assessment metric is that the target variable in our model is a continuous target variable, and the MAE is the best fit for a continuous target variable. Even though we have built three models, namely time series, seasonal edema model, K-tree and neural network, the main motto behind building the time series seasonal edema is just to forecast the number of appointments in the next academic year, whereas kite and neural network trees were built to analyze the number of appointments and then optimize the LASSO tutoring services. For this reason, we decided to assess only two models, namely K-tree and neural networks. Based on the MAE value for the spring data, the K-tree turns out to be the best model with the lowest MAE value as 1.74, and for the summer data, the neural networks turns out to be the best model with the lowest MAE value as 1.25. Similarly, for the fall data, neural network once again turns out to be the best model with the lowest MAE value of 2.5 as compared to the K-tree. Since we have built the models and have assessed them, now we would like to look into what we originally visioned and what we actually did. We have envisioned to measure the results based on the appointment patterns in the past compared to those derived in the models. We were able to determine the busiest weeks, busiest days, and the courses on high demand for a particular semester. We were also able to forecast the number of appointments on a particular day of an individual semester of next academic year, but we were unable to determine the busiest hour on a day because the day variable is spanned over a wide range with a minimal variance in the density of number of appointments, and also we were unable to measure the effectiveness of the tutor because there was no parameter which could help us measure the effectiveness of the tutor. We would like to recap the lessons that we have learned during the project execution. The first one is that the data preparation is the most crucial step in the CRISP-DM methodology technique because it constitutes almost 80% of the time that is spent on the project completion. And next, domain knowledge and business understanding is important for the project success. The objective of the project is subjected to change at any point in the project execution. The last is that we should have keen interest on analyzing the patterns in the data rather than frantically running behind the motive. We would like to make a few recommendations to the LASSO tutoring services based on our results. The first one is that in the spring semester, more number of tutors should be available for the courses maths, physics, chemistry, and accounting. And in the summer semester, more number of tutors should be available for the courses maths, engineering, science, and accounting. And also, the LASSO should be open on the Sundays. And in the fall semester, more number of tutors should be available for the courses like maths, biology, statistics, physics, and accounting. And also, irrespective of the semester, more number of tutors should be available for these courses on Mondays and Wednesdays. We have made these recommendations because we could see that there are more number of appointments on Mondays and Wednesdays, and also students are more enrolled for maths, physics, chemistry, biology, and accounting. Now we would like to discuss on the future scope of a project. We can do analysis at more comprehensive level in case we are provided with 3 or more years of the data, and also we can support the forecast with strong reasons in case we have historic data. We can perform the text mining on the data in case we are provided with the tutor feedback. Thank you for listening to our presentation with great interest. In case of any queries, please feel free to contact on one of our email IDs. Thank you.